All right, welcome class. It's great to see all you guys here. Looks like we have a lot of people on the line here, so it's great to see you guys. Last class period of the day, so hopefully you guys will finish this up pretty quickly, and then we can continue with the rest of whatever you guys have to get going. So first of all, I want to make sure that you guys know that tonight your homework is due at 3 p.m. So make sure you guys are doing that. When you guys are uploading your worksheets with your filled in answers, make sure you guys are in fact loading it up as like a document. That would be ideal, but make sure it's not in pages. I know a lot of people have been sending me these worksheets and they've uploaded it. They say like worksheet for science dot pages or something, and when they do that, I actually can't uh, uh, upload that on my computer. So make sure you have something that I can see. Usually I try to get back to you pretty quickly. So also what I've been kind of doing with that, if you have a few problems or if I can't see a problem that you did, I usually say, hey, Jed, make sure you go look through it and make sure you fix it as well. So I want to make sure you guys understand that. As I was looking through some of your papers, I was pleasant to see that some of you guys told me what you guys did over the spring break. So I want to say thank you guys for doing that. It was really interesting to hear that. For one of my classes, I missed actually one of my students' birthdays, so I was kind of unfortunate about that. She said she was quarantined pretty much the whole time, which I guess we kind of all are, but that's okay. I think she made the most of it anyway. Not only that, some of you said that you guys like ate a lot. You guys went sleeping. I guess that might be a sport for those of you who are interested in that. We also have Netflix. A lot of people were watching Netflix. So that was great to see you guys actually occupying or actually doing something over the spring break. And that was very encouraging to see as well. Not only that, we're going to go ahead and go over our worksheet at this time. So number 3 says interesting facts. Why do we have tides and waves on the earth? That is because of the moon. We have this gravitational pull that is actually happening when we do have the sun and the moon is affecting us on Earth here. Number 4, what is the study of God's creation beyond the atmosphere? That would be astronomy. You know, astronomy is such a fantastic science to get into because we don't really know. Actually, I guess I shouldn't say that, but we are still learning new things about the Earth and also about our solar system as well. So definitely something we could be interested in as well. That's something we're actually studying in this chapter. So I'm really excited for us to consider that as well. Number 5, who are individuals that study the motions of the heavenly bodies and the laws that govern these motions. Well, that's an astronomer, of course. Number 6, what galaxy are we in? Well, we are in the Milky Way galaxy, of course. I've already mentioned the solar system for number 7. The solar system is going to include all the planets. It's going to include the sun, all of the stars, a vast array of area that we're going to consider with that as well. Number 8 says, what is the process of an object circling around an object due to gravity? That is actually going to be an orbit. So I think today we're actually going to go through actually maybe a couple days, we're going to go through what a satellite is. There's a difference. They do in fact orbit objects, but we're going to kind of solidify what that idea is a little bit. But orbit, it's the circling around an object due to the gravitational pull that it has upon us. Number 9, Aristotle taught a blank view of the universe. That would be a geocentric view of the universe. We should pretty much already know what geocentric is. Geo meaning Earth, so we have here, I guess I should go on this side. I believe this is right. Here's our Earth. And then here's our sun. So the geocentric, that means everything is revolving around the Earth. So you can see here, I tried to make a diagram with this a little bit here. Maybe it worked. But the sun is going around the Earth, and a lot of people thought that that was how the solar system actually works. However, that's not necessarily true at all. Ptolemy, he was another guy. He wrote the book of Amalgamus, and then he's mathematically described a geocentric view of the universe, pretty much what we really don't believe now anymore, but that geocentric view of the universe. But now we finally have someone coming along proposing the heliocentric view of the universe. Helio, referring to the sun, of course. Now we have this idea with our sun right here. I made my sun on the board right here. And then we have the Earth that is circulating throughout our orbit, and I guess I should say orbiting around the sun as well. Not only that, we had our homework questions here. Hopefully you've kind of gone through those and understand those. It says, what does geocentric mean? I already kind of already went through that already. It's going to be the Earth that is going to stay stationary and all the planets going around it. What does heliocentric mean? Well, it's the Earth, the sun. Everything is revolving around the sun. And that is actually what we believe nowadays. We believe that everything is revolving around the sun due to gravity. Not only that, for number 3 of our homework, what is the study of God's creation beyond the exosphere? That is going to be astronomy. You know, astronomy is just an amazing area of science. Astronauts. I was actually looking up on YouTube today about some pictures about the moon. It was really interesting to see some of those pictures. Also, when they first landed on the moon in way back in the 60s, can't remember the specific date, but pretty amazing that even back then that they were able to have that actual technology even to get and land on the moon. So pretty amazing to think about. I want to bring your attention to something here, first of all, before we even start. Make sure you guys are turning in your homework. Your homework is 60% of your grade, so make sure you guys are doing that. If you're having troubles uploading that at the end of the class period today, I definitely want to go through with you to try to help you out with that. As I am looking on ThinkWave right now, I am trying to see what are some things, what other issues that we need to kind of solidify. Pretty much that might be everything we need to talk about today. So for today, what we're pretty much going to do, I guess I could look through our worksheet here. I did put, some of you who have uploaded the assignment, I have actually put in some comments for you. I suggest going through those comments, looking at them, and then making adjustments for that, because I want you guys to get really good grades, especially in this 4th quarter, even though we're not really at school. But make sure you guys are being diligent as well as consistent in doing your homework. That will definitely greatly help you as well. Does anyone have any questions before we start our class today? If you can raise your hand or wave at me, I can. Okay, Musa. Hold on, Musa. Is your mute button? There you go. Okay. Okay. All right. I will definitely take a look at that. Thank you. Anyone else have any questions? Questions at all? I don't see any hand raises or anyone waving frantically at me. Maybe Avel. There we go. Avel, I have a question. Avel, I can't quite hear you. Do you have like headphones or something to speak into? Hope you guys can hear me. Unfortunately, Avel, I still cannot hear you. I'm not sure what is going on right now. Hold on, we'll go to Mark real quick. Maybe we can figure it out. Mark, you have a question? So all of your worksheets should be online, and you need to go to that link. Either look at the questions and write them down, and upload like a picture for me on ThinkWave, so that I will be able to look at that. All of these assignments are due by 3 o'clock today, so make sure you guys know how to upload those things. Any more questions? Yes, we have Philip. Yes, Philip? That was it. Yes, everything on that page was all that was due for today. Yes. All right. Any more questions at all? All right, Avel. You have a question, Avel? Okay. For some reason, I'm trying to unmute you, but I cannot. All right. We might have to try after we get done with today in order to communicate, because I am not sure why yours is not working. Okay, we need to continue with our class period. So if you go on ThinkWave and actually pull up the worksheet that we have for today, it's going to be over the pages over 283 to pages 284. As I'm going to start the class period today, kind of an interesting idea. I didn't really know this, but this is definitely good to know. Number one, it says in your worksheet, number one right here, it says in ancient times, how many planets did astronomers know about? That is actually 5. There were only 5 planets that astronomers actually thought existed, and I thought that was kind of interesting, kind of cool to think about. However, they did go through some more scientific investigations, of course, and now we have more planets, of course. So, of course, we have the heliocentric view of the universe, where we have the sun at the very center of our solar system, with our everything orbiting around our Earth, orbiting the sun finally. However, the heliocentric idea wasn't as popular as it was really made out to be. But we had one person that actually came along, whose name was Galileo. Now, in 1610, Galileo came along, and he thought, as he was doing some experimentation on Jupiter, that he observed some more planets, some more moons, I guess you can say, things that were circulating around some of the planets, such as Jupiter. And so he found that the most important evidence for the heliocentric view of the universe. Very important to understand that. Not only that, he kind of established this idea that not only do these planets actually go in a circle, but they actually kind of go in an ellipsis. So kind of a different view. So right here, I tried to do my best to draw a picture of a circle right here. Hopefully you guys can see that. So here's a circle that we have here. A lot of people, you can see on the bottom of the page, and even in the middle section of pages 282 and 283, that this is how mostly that we're going to see some of these planets actually orbit. However, that's not necessarily true. When we had, let's see, who was this? Yeah, Johannes Kepler actually came around. He thought, you know what? Even though these planets are going in a circle, a circular pattern, I don't think they're really going in an actual perfect circle. What he ended up thinking about is that that's actually true. It's, they actually go in an ellipsis. So this is an ellipsis, kind of a different thing here. What we can do actually is that we can have 2 points in which there's actually a circle here. I'm going to try to do my best to actually draw a circle for you guys right here. There you go. Let me erase this right here that we have. So this is pretty much the path of an ellipsis. You can see here, here's our 2 circles, and then finally we're going to see that these paths merge, and it's going to go in a circular pattern. Notice the difference between these 2. I'll try to get out a picture here for you guys. But notice here, we have a circle that only has 1 point to them. However, in an ellipsis in which the movement of the planets actually travel, they're gonna have almost a shorter distance from north to south. However, from east to west, it's going to be elongated. So that is kind of the elliptical pattern that we see here, that planets actually move. And that's what Kepler actually researched. That's what he actually put his telescope into the sky and figured out. However, as he was doing, Johannes Kepler was actually doing this study, he had this idea and he made a couple of laws. He was doing some astronomy. He was an astronomer, of course. It says here on your worksheet, say 3 laws of Kepler's planetary motion. So first of all, the very first thing, so number 5, that Kepler found with his laws of the Kepler planetary motion was that every planet orbits around the sun in an ellipsis. So it always goes, not in a circle. Notice that there's a difference. An ellipsis is more of an oval shape. It's going to go kind of lengthways, really depending on the orbit, especially for the Earth. When the Earth actually goes closer to the sun, it's actually going to go faster. When it goes out, it's going to slow down and then speed up. So an ellipsis, that's kind of what he kind of discovered. So that is the very first thing that he that he solidified. The second thing that he actually had there, or kind of understood, was that they vary in speed. So this is very important. understand this. Imagine if we have, let's see here, I might have to erase my artwork, unfortunately, right here. So let's continue here. So if we have the sun, of course, the heliocentric view says that the sun is the very center of the universe. That Earth orbits, or since it's kind of a planet, that it actually orbits in an ellipsis matter. So here we go. Let's kind of draw our pathway of the Earth that we have right here. So let's have the Earth right here. Since we are kind of going into the springtime, the Earth is actually getting closer to the sun. That's why it's kind of warming up a little bit right now. So you can see here, as the Earth actually gets closer to the sun, the Earth is going to speed up. Notice that. Anytime the Earth is going to the sun, the Earth is going to speed up. However, what if it goes away from the sun? Well, it's actually going to be the opposite. When the Earth is orbiting and it is going away from the sun, it's going to slow down. So when the Earth is going in its ellipsis, going to the sun, it's going to speed up. It's going to increase its speed. Once it goes away from the sun, it's actually going to slow down. So notice that. Hopefully that is in, yeah, it is. Okay, great. So notice that there's a difference between these, and that's actually the second law that Johannes Kepler stated. He said that when the Earth or when any object is going closer to the sun in orbit, it's going to speed up. When it goes away from the sun, it will actually slow down. Number 3, he established this idea, and it is this: a period. So what is a period according to the astronomical terminology that we're talking about? Well, it's actually the amount of time a planet makes to orbit, to make one orbit around each other. So we've already actually established this in our calendar. Way back then, a lot of astronomers and people came together and said, these will be our 12 months, the Gregorian calendar, of course. And so how does this pretty much work? So when we have the sun, they've got my drawing, they're getting a lot of drawing for us today here. So if we have the Earth, in one day, the Earth is going to rotate, of course. And as it rotates, it's going to have a bright daytime and then a really dark nighttime. That's because the Earth is actually, again, the camera here is actually moving. So what Johannes Kepler said is a period is the amount of time a planet takes to take one orbit. That's his third law that he actually established. So as the Earth is traveling, going this way, oh yeah, we're having a great time. This is awesome. And then it takes about the Earth this time. This actually takes the Earth around 365 days equals one period. Kind of interesting, kind of a unique idea here. So if we have the Earth going around one time, that's actually going to be a whole year for us. However, notice that the sun, actually not really the sun, but the moon actually orbits every 29 days. That's why we're going to have our waxing or waning moon, our gibbous moons as well. And so notice that there's a difference. Not only the sun, or not actually, I shouldn't say the sun, because we revolve around the sun, but not only does the Earth go around the sun 365 days a year for one period of time, but the moon travels around the Earth in a matter of 29 days. And we're going to see the specific day for that once we get to the moon section, which I was doing some research on the moon section. Really interesting stuff. Really excited to get to that point as well. Number 8, what is the farthest distance from the Earth from the sun is called? So what is this idea here? So you see here, let's just stick to our diagram right here. So if we have, let me erase this, all this right here. So if we have this orbit that's actually happening, what we're going to have is aphelion. So the Earth over here is at the furthest distance from the sun. Look at this distance. All the way from here into here. So from here to here, we're actually, that's going to be the furthest distance that the Earth is going to be from the sun. That is going to be called aphelion. Hope you guys can see that. Not only that, what happens, of course, when the Earth orbits and it gets closer to the sun? So you can see here, what happens if the Earth was right here? Well, notice that we have this distance right here. Notice how close this is to the sun. This is called perihelion. There is a difference between these. Make sure you guys understand this. You see here, aphelion is the furthest distance the Earth is from the sun. What about the opposite? We always have opposites in not chemistry, but in science, I guess you can say. And you can see here the Earth, how close it is to the sun. That's going to be much closer right there. And that's called perihelion. Very important for you guys to know as well. However, what is the measurement in which planets, number 10 right here, what is the measurement in which the planet's average distance from the sun called? So notice something. We already know when the sun is in aphelion, it's going to be the furthest distance away from the Earth and from the sun. But what are the specific areas? Is there a measurement that you can actually tell me how far this actually is? And those are actually measured in astronomical units. So we need to use astronomical units in order to tell us the exact location where the Earth in fact is. Notice, we can say 93 million miles is probably the average distance from the Earth is from the sun. So let's see if I can get this on here. So 93 million, so we need 6 zeros. I think I might be even going off the screen here. So 93 million miles is the amount of distance that the Earth is from the sun. However, that's actually not necessarily true, because since the Earth is orbiting, and since that the aphelion difference from the perihelion, it's going to get closer. So actually every day the Earth actually sometimes gets closer or further. So 9 million miles isn't necessarily an exact distance. So make sure you understand that as well. Number 11 says this, true or false? It says, Kepler discovered his second law of planetary motion first. Yes, he actually did. Kind of weird, because, sometimes in science, it's just confusing stuff. So if you kind of notice something about Kepler's second law, is that he actually discovered that first. So kind of interesting. When we go to the plant world and we go through photosynthesis, we have light reaction and dark reactions that are actually happening with plants. Plants actually need light and darkness because of the chemical reactions that are actually going through the plant. So it is good that plants actually do get light or darkness. However, scientists actually figured out that the light or the dark reactions first. Kind of interesting. I think it's called photosynthesis 2. So when you guys get in biology, we study photosynthesis. They actually study the photosynthesis 2 first, and then the second one, photosynthesis 1, they actually study the second. I know that might be kind of confusing for you guys, but that's kind of an interesting fact as well for us. As we're ending our class period for today, you have homework for tonight. You have numbers 1, 2, and 3. I want to make sure you guys see those as well. Very important information for you guys to understand. The next time we meet, hopefully we're going to be talking about Newton, because Newton had some final ideas regarding this idea of astronomy. So very important information. That is actually the end of our class period today. If you are free to go, you don't have any questions, you guys are free to leave. If you do have questions, please, please, please stay on the line. I want to make sure you guys understand everything that is going on. Notice that tonight's, when I assigned yesterday's homework, it needs to be uploaded today by 3 o'clock. So you have 30 minutes to get that finalized and everything put away. If you guys are ready to go, all set, you guys may be dismissed. I'm going to stay in the line and answer some questions here. So Mark, yes. Okay, so all of these questions are actually in your book except the first one. The first one is 5 planets. In ancient times, how many planets did astronomers know? That would be 5. All the other answers you should actually know. You can actually get the information from your book, or you can even go back on YouTube and even watch our presentation for today. Make sense? Okay, great. All right, so I saw Gustavo, yes. Yeah, what you can do is you can even write on a piece of paper, take a picture of it, and upload it to ThinkWave. I would accept it that way as well. Oh, okay, if you put it in like a JPEG, it's not JPEG file, then I can accept that. So there you go. Kathleen, I think she's laughing at me because I just said JPEG, but that's all right. I'll survive. Sounds good, Gustavo? All right, excellent. So, Philip. So if I got what is it called? You know, I can actually check. Let's see here. Yes, so it looks like you're missing question number 3. So yeah, you didn't even do question number 3. It was blank. So I want to make sure you get credit for that as well. If you can upload it, or even if you could show it to me now, that'd be great. All right, excellent. All right, so Jed, and Mr. K, thanks. See, 1 second here. Number 2, you should actually know that. That is actually in your book. Okay. All right, so I think Jed is unmuted. All right, anyone else? So Caleb Love. All right, Caleb, yes, question? They are on pages 283 to 284. Okay, are you all set? Okay, excellent. So Gustavo, I want you actually to stay on the line for a little bit. So I want you to be the last person that leaves, all right? Okay, and then Ashley, yes, question. Oh, okay. All right, great. I will write myself a note right now, and I will look at it right after this. All right? All right, excellent. No problem. All right, so we have. All right, so Mark Fremont? Yes, it is. I'd make sure you take a look. All right, so Philip. Okay, there you go. Very good. Excellent job. And the questions, they should be, yeah, they should be in your book. Yes. Pages 281 to 282. So for your homework, yes, because we pretty much cover that in class, and that should be in your book as well. For tonight's homework, let's see here. Yes, they should be in your book. Yep. 283 to 284. Yep, you're welcome. All right, let's see. We have Mark. Do you have any questions? All right, so if you are done, you may leave the meeting. We'll see you guys later. I also have someone on the bottom of the screen, or on the bottom right. So, Philip, are you ready to go? Oh, okay, there he goes. And then, not sure who this other person. Okay. All right, so Gustavo, 1 second. All right, so you want to talk to him? No, just tell him. Okay. All right, so Gustavo, I'm just going to tell you how it is when you change your name. All right, we make sure we're being appropriate. Of course, my classroom.